Hi, I'm Kian, and today I want to show you how to solve this integral. We have the integral of x plus square root of x plus square root of x, which just goes on forever dx. So, first of all, because we want to make our solving possible, because we can't integrate this; it's impossible. I want to write this expression in another form. So, I, for example, call the whole function as f of x. And using clearly the properties of functions, I can say that this is just the square root of x. And if you see, this is repeating. Square root of x plus square root is just repeating. So this is just f of x is square root of x plus f of x again. This is just repeating forever. So now, because I want to solve for f of x, because I want to know what my exact value of my function is, first of all, I square both sides. So I get f of x and then squared is just equal to that. If we square the square root cancels, and we're just left off with x plus f of x. Now I want to subtract x and f of x from both sides. So I write it here. Let me change the color. I can write it as um, f of x squared minus f of x, and then minus x is just equal to 0. Now, I don't want to solve for x. Instead, I want to solve for f of x. So I can use our quadratic formula to see that f of x, using the quadratic formula. So this is just minus p. In this case, minus and minus cancels. So we get 1 and then plus and minus the square root of b squared, which in this case is 1 again, and then minus 4ac. So when we say minus, in this case, our constant is not -1, it's negative x. So if we simplify it, we get 1 plus 4x, and then divided by 2a, which is just 2. And now, if we look at it, if we plug in different values for our expression x, so in this case, we have two scenarios. Either this is plus or minus. Um, when we want to check for minus, if we plug in different values for square root of x, for x, we see that the whole thing, f of x, becomes negative. And we can't have a negative answer, a negative outcome in a square root like our original function. So in this case, we can ignore the negative sign. So we can just work on with the first situation, which is 1 plus square root of 4 plus 4x over 2. So now I can just integrate this. So I can write it as a different color. The integral of, I can take out the 1/2. So I get 1/2, and then times 1, and then plus the square root of 1 plus 4x. Let me write it a little more clear. 1 plus the square root of 1 plus 4x, and there's a dx at the end. So now I can clearly take out the 1/2 because it's a constant out of the integral, and I can use a u substitution maybe. So this is a 1/2 times the integral of 1 plus square root of 1 plus 4x. dx. And now I can use a u substitution. So I let u to be equal to inside of the square root, or 1 plus 4x. When differentiating both sides, I get du is just 4 times dx. And if I want to solve for dx, it's easy, just divide both sides by 4. I get dx is equal to du over 4. And now I can just plug in. Now, when I plug in, now you see that when I plug in dx, because we want to take the integral into the u world, I have a constant of 1/4, and I can take it out of the integral. So I get 1 over 8 when multiplying 1/4 and 1 over 2 times the integral of 1 plus, and let's write it as u to the power of 1 over 2 because it's easier to use the power rule. And now we can just integrate u to the power of 1 over 2. If you use the power rule, this is equal to 1 over 8, again times the quantity. This is integral of 1 is u, and then plus, using the power rule, this is just 2/3 times u to the power of 3 over 2. And because we started our integral in terms of x, I can write this as my final answer, which is 1 over 8 times u is what is u. This is 1 plus 4x, 4x, and then a plus 2/3 times 1 plus 4x, and then to the power of 3 over 2. And this is the final answer. And you can feel free to simplify the answer, but this is the final answer. Thanks for watching.